All right, number 15, graph each system of equations. That's why you have your graph paper. Then determine whether the system has one solution, no solution, or infinitely many solutions. And then it says if the system has one solution, name it. All that to say, you want to take those two equations and you want them to be graphable. So you're like, what do you mean by graphable? Able to be graphed. Y equals negative x plus 8, and then y equals 4x minus 7. Okay, what I want to do when I'm graphing lines or inequalities is I want to get those lines or inequalities in this format. Y equals mx plus b. Does anyone remember what m stands for? Slope. And that is a fraction. Mr. A, it's not a fraction. You can make it into a fraction, but that's your rise, whether you go up or down, over the run. And then what's b stand for? Y-intercept. And that's actually where you start your graph. You start at the y-intercept, then you go with your slope. And let's do that for this problem here, number 15. Do you notice anything about these two equations? They're already in that format, which is really nice. So I'm going to go ahead and graph. This one's going to be a tall graph. How do I know it's a tall graph? Look at my y-intercepts. I have positive 8 and negative 7. So I got to go all the way up here and all the way down there. It's tall. And Mr. A's graph is not going to look as pretty or as neat or as accurate as even your graph because you have graph paper, and on your test I'll give you a grid. So you can do that hopefully more easily than I'm doing here on the board. On the first equation, where should I start my graph? On this, don't do it by twos. That's a good question. Don't do it by twos because it gets our slope messed up if we're going up 1 over 2 or something like that. And I won't make them. I'll make them so you don't have to go up by twos. But we're just practicing on this one. So where do I start this graph? Oh my. 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put it more where it should have been. So like right there. And then what's my slope on this first graph? Negative 1 over 1. So I'll go from that top point down 1, over 1 to the right. Down 1, over 1 to the right. Okay, and I'll connect it with a line as best I can. All right, that's my first line, and then I have to graph the second line on the same coordinate plane. So where do I start the second line? Negative 7. So I go 1, 2, 3, 4, 5, 6, 7. And I'm just telling you right now, guys, you always start the y-intercept on the y-axis. Okay? I hope that makes sense. Don't ever put a point first on the x-axis. Always on the y. And what's my slope?
4 over what?
4 over 1. 1, 2, 3, 4. 1, 2, 3. Okay. I just don't use it. It takes me a while, but I might as well do it for this problem. Do these two lines intersect?
Yes.
Okay, that intersection, or that intersecting point, should be the solution. What's the ordered pair that matches this point? Ordered pair. What's the ordered pair? Yes, okay. 3, 5. 3, 5. Now, is 3, 5 the same as 5, 3? You've got to put which coordinate first, always. Which coordinate? The x coordinate, then the y coordinate. Okay, so my answer is going to be 3, 5. Now, that point is the solution for both equations. How many solutions did the top equation itself have? How many solutions the top equation have? It had infinite number of points. Or sorry, infinite, it's this one I think. Infinite number of points. The second one had an infinite number of points. How many do they share? 1. And that's your solution. 3, 5. Okay. Go ahead and do number 18. And it's a little bit tougher. What do you want to do with those two equations? Get them into slope-intercept form. Get them into that form. Get y by itself, basically. Yes, sir?
So for our homework, it's just like graphing.
For this lesson. And 5. Dash 5. And other ones later on. Okay, so we're going to do number 18. You can do it on your own. Try to get that one done. Okay, you want to solve for y on both of them? And actually what I'll do is I'll write them side to side. But solve for y on the first one, and then I'll solve y on the second one. And then you do the same thing over here. Hopefully you did that already. Whoa. Deja vu. I've been here before. Yes, ma'am?
I do.
Thank you. For offering. Okay, so here, you have a great question in your mind right now. Do I have to graph it? Of course you do. It says graph each system. How many lines do you have to graph? 1. So consider yourself lucky. And this one, it really shouldn't be too hard because you're not trying to make them intersect. Okay, what's your y-intercept on this problem? Good. 4/3 is 1 1/3. So I'm going to go up 1 1/3. You can just estimate. That's about there. A little bit less than half. Okay, so I have my 1 1/3. And then my slope is down 2 over 3. So from this point, I'm going to go down 1, 2, over 1, 2, 3. Put my next dot. And they're both the same, right? So I didn't have to do it again because I already did it. What's my solution?
Infinitely many.
Infinitely many. Sorry, I didn't mean to do that. Infinitely many. Winner, the first rookie to come out of a 3-0 hole. First. Yes, ma'am? Yeah, this is at 1 1/3. Because you see 4/3 would be 1 1/3. If I change it to a mixed number, it's 1 1/3, so over 1. By the way, your estimates on that first page at least, has anyone not taken the test? The test that we took Friday? You guys didn't take it? Okay. Oh, I can say this because it's not revealing. Your estimates were very good. I was very impressed with a lot of them. Not only a few people got them all on the first page, right? But a lot of people got 2 out of 3. Very impressive. To the 10th, boom, right there. I was like, what? Supposed to make that tougher. So you don't have to, which not everyone tried, which is okay. Okay, what if I have a solution, one solution, and infinitely many? How do I get a no solution? How does that come out? Parallel lines. Parallel lines. If I have the same slope but different y-intercepts, you have to graph them, and you say no solution because they'll never intersect. Okay, that's 8-1. We're done with that.
So if you're about to look at a graph and you're like, hold up, maybe you put no solutions.
No, if you wrote some of this down, it's like partially. But I want to see a graph. I want to see a graph. Sorry?
What if our graph is wrong? Then you get the problem.
But you still
Yeah.
Well, we get the problem.
Oh, okay. Yeah, you lose some points. Not all.
How would you know? Would you look at it?
Yeah. Yes. The answer to that, yes. Yeah, I looked through, and this is what I've done in the past. I looked through every single problem of every single person. So this is not new, but it is hard. It takes a long time. I don't have that time. I need 3 hours to grade this test, so I have to get it done quickly, because we have to get your grades right away. Okay, page 467, or excuse me, 466. 466, we're using substitution. So how many of you already, even with that last example, with that 1 1/3, how many of you feel like graphing may not be the easiest method to use, right? 1 1/3, and then you're going down 2 over 3. It can get very inaccurate. So there's got to be better ways than there are. Page 466, do number 10. Taylor, can you read number 10 for me?
Y equals 3x, and x plus 2y equals -3y.
Okay, so I get these two equations, and could I graph them to solve? Yes. But we're to use substitution. Does anyone remember substitution?
I think you do, don't you like subtract it or something?
I think you're thinking elimination. Elimination, which is the next.
I know.
Ellie?
Now I remember.
It's like you thought, like, over here, y equals 3x, you put 3x in for y, and
Okay.
then you only have to solve for x.
Good.
You put that x in for y, and then you do it all again with y, and find answer to y.
Yes, I think I follow. Yep, that's it. What you want to do, your goal on these problems is to get one of the variables all by itself. And guess what? One of them is by itself. So do you see how y equals 3x? So doesn't this y right here equal 3x? So I'm going to substitute 3x into y here. So I'm going to put x plus 2 times 3x is equal to -21. So I substituted y with 3x. So that's what I did. Instead of this y, I'm putting 3x. And then I can solve for x. Don't forget your order of operations. And to be very careful with your signs. And then to write your answer in a correct way.
Sorry,
Oh, always entertaining. All right, did you guys get your x equals -3? Yes, got my answer.
Yay.
What else do I need? I need what y is. So here, I can put it into the top equation or the bottom one. Which one's easier? Top. Someone say bottom? Oh, sorry. I thought someone said bottom. And that's okay. Could the bottom one work? Of course it can. All right, what's my answer? -3, -9. Can I switch them around? Be okay?
No.
No, so make sure you put your x coordinate, then your y coordinate.
Oh, I
Now,
like elimination.
yeah, it depends on the problem. And yeah, you may like that one. That's good. I would say you can always check these answers by doing what? Always. You can graph them.
Substitute.
If these two work on which one?
Both of them.
Second.
And then my-
It can be one, but it's not. If it works for one, it doesn't work for the other.
Okay, this solution, in order for it to be correct, has to work for both. So if you check it on the first one, oh yeah, it has to be it. Well, technically not, because how many answers does this have? Infinite, right? This one has infinite, but there's only one solution that fits both. So if this works in both, you have to be correct. I'm not saying anything about that anymore.
So should we go and check that now?
No, don't check it for now. We're good with this. Okay, I think I'm done with that. 14. Go ahead. Do number 14. Tougher one. Don't be afraid of fractional answers.
We just do elimination.
No, do substitution. Sorry. I know you want it. It's good because it would work very nicely.
Yeah.
I know. The cruelty.
You're going to have to re-explain that to me because I don't remember how to do
That's okay. I will. Now I'm more comfortable. Okay, let's go with number 14. Ellie, read it for me.
Okay. 2x minus y equals -4 and -3x plus y equals -.
Okay. No, because you want to get practice with substitution, because I will give you a problem with substitution. You can't do elimination unless you want to make it really tough. Because sometimes elimination is easier, sometimes substitution is easier, and then sometimes graphing is even easier.
I remember. Okay. Yeah, I just didn't remember how to do that. But I remember.
Okay, your goal on substitution is to get one of these variables by itself. So which one you think is easier, the y up here or the y down there?
Y down there.
Okay, could you have even solved for this x or that x? Of course you could have. It just makes it tougher. So I'm going to say the y down here. So I get y equals -9 plus 3x. So I just solve for y. Then I substitute that back into the top one, and I get 2x minus, okay, remember it's minus y, so minus whatever this is. Okay, so I have to make sure I get my signs right because it's really easy to mix those up. Plus 9 minus 3x equals -4. Add like terms. I get my -x plus 9 equals -4. What does x equal? 13. Positive or negative?
Positive.
Okay, how do I find my y? Which one? Yeah, when you plug it in to find another variable, you can plug it into either one. But when you're checking, if you really want to make sure, it has to work on both. So I'll put in the top one. 2 times 13 minus y equals -4. What do you get for your solution? 13. 30. 30. It messes up. I'll leave that up for just a moment. Go to page 472 when you're done with that. 472. Oh, elimination comes back here. The Cavs will be eliminated next round. I'm using it as a vocab word. The Cleveland Cavaliers will be eliminated next round. The Cavaliers have faced elimination many times. The Cavaliers have been eliminated by the Warriors several times. The Cavaliers will not be eliminated by the Warriors this year.
Well, because the Cavaliers beat them.
That's one way to interpret it. Okay, I'm going to move here. 472. Number 5. It's a nice, easy one here to start us off with. Elimination.
Do you add them?
Yes. Add the equations. And if you don't get what to do here, look up on the board and I'll help you out. Because I want you to know, again, why you're doing it. Okay, another method other than graphing and other than substituting is I can add these two equations together. What's 3x plus 4x?
7x.
7x. What's -5y plus 5y? That cancels out. And then what's 3 plus 4? 7. Now, when you're using elimination, here's why I'm telling you guys elimination is not always nice. Because in these problems, like in this problem right here, Do you see how I have my x's and my y's and my constants all lined up nicely?
Yes.
Okay, that may not happen, and sometimes I don't have a y, I don't have a constant necessarily. So what I want to do is make sure that they're parallel. So I have my two variables on the left and my constant on the right. So this is all, it's primed to be eliminated. So what do I get for x? 1. Nice. X is 1. That's the next lesson. Yep. We'll definitely get to that. You could do by 1, by -1, by any number to make it do what you want it to do, which is really cool. Yep.
Wasn't there like another way? So like, if you wanted to find y, you would make x like 1 or 0 or something.
There is another way, and what's cool is you could do any one of these problems can be solved by any method. Some are easier than others, but we'll get to that next lesson. Here it's just straight up adding or subtracting. So if x equals that, what does y equal? If you put it back into... Okay, 0. And you notice it's not nothing, it's 0, because 0 divided by -5 is not nothing, it's 0. Okay, so here's my answer. And does it work in both? Yes. Next lesson, since you guys are so eager to get to that. 478. Nope. It's pretty straightforward. Boom. That's how you do it. But let's go to 8-4. And here's a little one for you. Simple one. It's actually not that bad. Wait, did I really pick that one? Fine. Number 8. Margot, read for me number 8, please.
4x plus 7y equals 6. 6x plus 5y equals 20.
Okay, is this in parallel format?
Yes.
Like parallel. Mm-hmm. So now you're looking at it saying, if I just add it, I'd get 10x plus 12y plus equals 26. Did that do anything for me? No, so I have to think, which variable do I choose? You can choose which one you want to eliminate. You can either eliminate the x's or the y's, but you can't do it just like it is. Which one do you want to eliminate, the x's or the y?
Definitely the x.
Okay, raise your hand if you want to eliminate x. I don't know why x is so hated on, but who wants to eliminate y? Y. Y. Okay, I think I have x. Sorry, x was the most common. Okay, if I were to get these two to be the same number but opposites of each other, I can eliminate. So what do you multiply? What do you think I should do? Like, what am I thinking of? And actually, someone from the other class, they gave me the actual term. They said, find this. I'm like, how do you remember that? What do you call it? Looking at these two numbers, you really want to get the blank, blank, blank. Not the least common multiple. What's the LCM of 4 and 6? 12. So if I multiply this by 3 and that by 2, yeah, one of them has to be positive, one of them has to be negative. So let's just go to the top. I'm going to multiply by -3 and the bottom by positive. Okay, so this is how I show it. By -3, I said. And this is by positive 2. Excuse me? No, and you're right, but I am going to do the same thing to each side of an equation. So that's allowed, and then I can add them together, which is nice. It helps me out. All right, I'm going to get -12x minus 21y equals -18. Oh, man. Just made that problem tougher, right? I went from this to this. That made it easier? I don't know. All right. Sorry, Beth? It could have done positive, but you want this number, one of them to be negative, one of them to be positive. Yep. Yep.
Why didn't you use substitution?
Excuse me?
Why don't you just do substitution?
I thought elimination's easier.
Well,
It depends. Yes, you can subtract. I read your mind. Did I read it? Yeah. Okay. And yes, you do it. Just be careful. Okay, and then the bottom one I'm going to get 12x plus 10y equals 40.
I thought it was negative. Is it not negative? Oh, never mind.
Sorry.
Okay, never mind.
Okay, Man, I made these tough. But now, can I just add these together? Let's see. What's negative 12x plus 12x? Eliminated. What's negative 21y plus 10y? Negative 11y. What's negative 18 plus 40?
22.
22. Oh. What is this? Oh, negative 2. Yes, I'm done. Move on.
No, you cannot do that. Don't do it.
Give me the other one now. Sorry, do it on your own. Sorry, I'll let you guys do it on your own. I'm sorry. So you notice to get the first variable, you can use one of the methods, but really the second variable is always going back to substitution, basically. You can use this equation, this equation, this equation, or that equation. I would use this equation, but that's me. So I'm going to substitute it back in here. Okay, does it work for one or the other? Both.
It's 2 and 2.
Okay, just when you thought it was over, one last lesson, 8-5, page 485. You're like, Mr. A, I had this graph paper and I didn't even use it. That's correct. Pizza's never tasted the same since going on a gluten-free diet. That's all I have to say.
Have you enjoyed your gluten-free diet?
3 months almost. I went 4 months before, and then I had gluten. Yeah, she kind of is now.
Is Swivl too?
They are kind
Is he still eating carrots?
of. Pause, Swivl. Hold on. Gotta answer that question. Excuse me?
Is Swivl still eating carrots?
Like a horse?
Well, no, we said like a bug. Horses don't really eat carrots, that's right.
Yeah, they do. They really don't.
Mr. Ed, do you know who that is? Do you guys know who Mr. Ed is? He ate a ton of carrots. Like, excuse me? Look him up, Mr. Ed. Okay, sorry, so we had to hear that. Let's continue. He's like, it was like an old, I never even grew up watching it, but it's like an old sitcom. It's a horse that talks.
I've never noticed any barns or
That's kind of cool. All right. Enough of the laughing. 45. Okay, go with number 10. It says to solve each system of inequalities by graphing. So you're like, oh man, inequalities. I want to get it into this format still, the slope-intercept. I still want slope-intercept. Kendall, read for me number 10, please.
Y minus x is less than 1, and then y minus x is greater than 3.
Okay. Yeah, and those signs, remember which ones they are. Those are hard. I got to keep track of those. When you're graphing inequalities, you graph them just like lines except for 2 things. Do you remember what the 2 things you have to keep in mind with inequalities? You have to have what? Dotted or solid. Okay, so dotted, so it's going to be a solid line or it's going to be a dashed or dotted line. And then there's another thing you have to keep in mind. Shade. You got to keep shade. And you can even see that on page 45 right underneath it. You have your solid, your dashed, and shaded parts. Okay, so what I'm going to do is I'm going to solve for y on both of them, and I get y is less than, I'm going to put x plus 1. And then I'm going to have y is greater than x plus 3, because I like it in that format. Now, there is another thing you have to consider based on your understanding of inequalities. If you multiply or divide both sides of an inequality by a negative, what happens? The sign has to change. It has to change direction. So did we do that here? No, we added or subtracted, which does not affect the inequality. Okay, so I'll graph this here. Go ahead and graph it if you haven't already. Go right here. I'm just going to graph these just like lines. So I start at positive 1. And what's my slope on that one?
1 and 1.
1 over 1, 1 over 1, 1 over 1. You can go the opposite way.
Everything less than. That's a little off.
Yeah. Oops. Is it a solid or a dashed line?
It is dash.
Why?
Because it's just less than and not less than or equal to. So it's not on that line. It's
No,
less than.
Mr. Egg, no, Mr. Egg, no. It has to be dotted.
Hey, good, don't worry.
So, yeah, sorry. Yeah, and the eraser doesn't work well with this, but some of you did this on your test, which I thought was okay. How many of you did that? Was it you guys who did that? You drew a line, but then you drew dashes next to it? Okay, good. Don't do that, because that makes it confusing to me. So here's my...
That's basically cheating.
That is so
Because you're saying it could be both.
Yeah, so avoid it. And don't worry, because you won't have that, like I won't do that on your test. I won't give you that option. So it'll either be dash. I think it was, I don't know. Okay. 3, 1, 2, 3. And then it's still up 1 over 1, up 1 over 1. Yep. Dash line.
Yeah, it doesn't matter if it's parallel.
Okay.
No, it is.
Now, I still have to do what? Shade. Okay, so listen carefully. Let's look at the top line. Y is less than x plus 1. So that would be this line, right? Less than would have been, and I shade, some of you do this too, you just kind of shade lightly with your pencil so it's easy to erase. That would be the top line. The bottom line would be greater than x plus 3. So wouldn't I shade this part? Okay, what's my answer?
No.
Excuse me?
No solution.
No solution. Why? Because is there any part of these shaded regions that overlap? There's no solution. So if I had this overlapping the top part, then I would keep that as the solution. But here, is there any overlapping shaded part? No solution. Okay. What happens if there was? Great question. Number 8.
Number 8.
Yes. Yes. There. Josh, can you read number 8 for me, please?
Y is greater than or equal to 2x plus 1, and then y is less than or equal to negative x plus 1.
Oh, sorry?
Plus 1.
That's okay. On this equation, or this inequality, or these inequalities, don't we have them both in the right form? Ooh.
Are we on time?
Sorry, Swivl. I did give homework. It's 9 problems.
Are you kidding me?
Yeah, so please write this down. It's weird. And write these down because, like I said, it is weird, but it'll make sense once you see it. Yes. Is that the question of the hour? Margot.
Yes, sir?
You asked me if these tests in the back are beneficial. And they are. You need to do that. You're not doing all the problems, you're just doing just those problems.
On each lesson or just?
Yes, let me give it to you. Just a moment. This is chapter 8 test. You're doing these problems from that chapter 8 test. There are no answers in the back. Yes, take the test on these parts. Goodbye.